Everybody, hi. I'm so sorry that I couldn't be with you. Unfortunately, I was sick, but I really look forward to it. So thank you so much for coming today. I'm sorry if I will have like cough from now and then. Let's hope that it will never happen. But today we're going to talk about how to build centralized policy management at scale. So one question, who's here is already using Kubernetes in production? Wonderful. Who's here accidentally took down production? Okay. Well, interesting. So before I begin, I believe that this is the first time that we meet. So hello, everybody. Let me just fix it. Hi, my name is Noaa Barki. I'm a developer advocate at The Tree. I've been a full stack developer for about 7 years. I'm also a tech writer and one of the leaders of GitHub Israel community, which is the largest GitHub community in the whole universe. And I also work at an amazing company called The Tree, where we help developers to prevent Kubernetes misconfigurations from ever reaching production. But enough about me. Today we're going to talk about how to build centralized policy management at scale. And specifically, we're going to talk a lot about policies. Why do we even care? What does it mean? Why should we have policy enforcement? We're going to review some of the very cool tools that I like, such as Opa, Gatekeeper, Conftest, Argo CD, and my very own The Tree open source project. So without further ado, let's just start it. Everybody, please close your eyes. Picture this. You had a long week and it's Friday now, and you're in your bed dreaming peacefully about a warm, cozy, wonderful weekend. However, fortunately, your weekend came a little sooner than expected. At 3:45 a.m., when you woke up from the sound of your phone and you had 15 missing calls from work, you wake up, you wink your eyes, and you go to your Slack channel and looks like, oh no, apparently somebody forgot to put a memory limit in one of the deployments, which caused a memory leak in one of the containers, and there it goes. The production is down. All Kubernetes nodes are ran out of memory. Oh, wait a second. Oh no. Oh no. I think that person is you. Now, I'm totally kidding. This is a completely imaginary story, and I know that it will never happen to you. First of all, you're very responsible. You're here with me, that's for sure. And the second reason is that I know that you know how to use Kubernetes, and forgetting the memory limit, come on, Noah, what are you talking about? So I have a different question. Who's here ready to play a game? Come on, you guys, who's ready to play a game? Okay, so I'm very excited to invite you today to my very own private show, What's the Mistake game show. So the game goes like this. I'm going to show you 2 Kubernetes manifests. Each time I'm going to point into a specific key which is configured differently on every manifest. You will have to look very carefully and tell me which one you will deploy, left or right. This is a cron job configuration. Pay attention to the concurrency policy. Which one you will deploy, left or right? I should have had like a ticking clock or something like tick. So anyway, who's here? I'm sorry. Who's here says right? Who's here says left? And the right answer will be right, of course. We always want to make sure that we set the concurrency policy to either forbid or to replace. The reason why is because whenever a cron job will fail, the next job won't replace the previous one. And this is actually something that happened to Target. They had one failing cron job that created thousands of pods that were constantly restarting. And not only that, it took their cluster down pretty much immediately. Their API server also accumulated hundreds of CPUs during that time. So it also cost them a lot of money. And this is a very sad story, but let's move forward to the next question. This is another cron job configuration. And once again, pay attention to the concurrency policy. Which one you will deploy, left or right? Who's here says right? Who's here says left? And the right answer will be right again. You see, on the left side, the concurrency policy isn't part of the cron job spec. So we end up with a cron job without any limits that will just keep spawn pods that will never be cleaned up from the API server. And this is actually what happened to Lando, which is an online fashion company with over 6,000 employees. They actually used the correct configuration this time. However, they placed it incorrectly in the YAML, which eventually caused an out-of-memory issues. Very sad story. But let's move forward to the last question. This is an innocent pod. Which one you will deploy, left or right? Who's here says left? Who's here says right? Wonderful, of course. We never forget the memory limit. We don't want anybody to wake up at 3:45 a.m. And this is actually something that happened to Blue Metador, which is, I'm sorry. Oh, I forgot. No, I didn't forget. Sorry. The right answer is right. And this is actually what happened to Blue Metador, which is they were a small startup company, and their pods hosted a Sumo Logic, a third-party application whose containers were memory hogs. And because they forgot to put the memory limit, nothing basically stops from those pods to take up all the memory in the nodes and basically cause system out of memory issues. Now, Blue Metador, Lando, Target, they aren't the only one who suffered from, let's face it, pretty innocent mistakes. I'm talking about big companies. I'm talking about Google, Spotify, Airbnb, Datadog, Tesla, who isn't there. I'm talking about a lot of other companies who share their own Kubernetes failure stories. So first of all, I highly recommend everybody to read about other companies' failure stories. Not only that you will learn so much about Kubernetes, how it works under the hood, what to do, what not to do, and what are the best practices, but it will also make you ask yourself the ultimate question. How can I make sure that it will never happen to me? And this is a very important question because it forces you to think about what are the requirements of your workload? What is the security and the stability that you want to achieve for your production, and how do you get it? How can you make sure that you won't become one of those failure stories? And the answer will be policy enforcement. I know this because before we launched our product at A3, we wanted to learn as much as possible about the common pitfalls and the common misconfigurations in the Kubernetes ecosystem. And what we did was that we read more than 100 Kubernetes failure stories. And not only that we learned that policy enforcement is the way, is the solution to prevent misconfigurations from reaching production, but we also surprisingly found out that policy enforcement is the key or a key solution to improve and nurture the DevOps culture in your organization. Great. So how do we start? First of all, we want to define the policies and the rules that we want to enforce in our organization. Maybe we want to make sure that every container has configured a memory limit. Maybe we want to make sure that every container has a liveness or a readiness probe. Maybe it's not about containers. Maybe it's about cron job, that every cron job has a deadline, or is that the scheduler is valid. Maybe it's about deprecation or security. It can be whatever you want. But the policies that you will define are really dependent on your workload's requirement. But once you have a set of policies, the real question will be, how will you use those policies? How will you distribute those policies and integrate them in your pipeline, in your organization? How will you make sure that you and your teammates follow these policies? Now, I believe in two things. I believe in shift left, and I believe in GitOps. I believe that as soon as you find a mistake, the less it might take your production down. And every Kubernetes resource, every config file should be handled exactly the same as your source code. So with this mindset, the way I see it, we should automatically validate our resources, our manifests on every code change, exactly like our source code in the CI. Furthermore, in integrating and validating your Kubernetes resources in the CI with tools that can be used as a local testing library can extremely help you nurture the DevOps culture in your organization. And the reason why is because developers, they're used to local testing library. They're used to write code, test it locally on their local machine, and then submit a pull request. And they expect at least those tests to be run again in the CI. This is actually part of their policy. So allowing the developers to do the same with Kubernetes resources, with infrastructure as code, will allow the DevOps to delegate more responsibilities to the developers, and therefore to liberate the DevOps from the constant need to fence every Kubernetes resource from any possible misconfiguration. Now, I'm not there, but I hear you. I know what you're thinking right now. You're thinking, come on, Noah, let's talk business. So here in Israel, we have a saying, it's called, let's talk dugri, which means show me the real business. So let's talk about how you can start today, build your own policy enforcement for your organization. And the first tool that I want to talk about is OPA or OPA. I'm going to call it OPA from now on. So OPA is a general purpose policy engine. You can write all your policies in it and query it with a specific input to check if it violates any one of those policies. You can practically think about OPA as a super policy engine. Now, the main idea behind OPA is to decouple the decision-making logic from the policy enforcement usage. So suppose you have microservices architecture, and one of the microservices receives an API request. Now, you probably need to make some decisions in order to, you need to make some decisions in order to allow or disallow this request, right? Right. Now, these decisions, they're based on rules. They're based on criteria that you want this request to meet. These rules, they're called policies. And what OPA gives you is the ability to offload all those policies into one dedicated agnostic service, and therefore to provide the administrators and the ops team in your organization to gain more control over the policy enforcement, the policies, and the service at runtime. Now, to use OPA, there are actually two ways. If your services are written in Go, then you can use OPA as an internal package and just embed it within your code. If not, if your services aren't written in Go, then you can use OPA as the host level daemon and simply query it with an HTTP request. You send OPA your input as a JSON with the policies, or you store the policies in OPA. OPA will evaluate the input and will return the response, valid or not. Now, this is important. By definition, all the policies should be written in a special language called Rego, which is the official policy language of OPA. It's very easy to learn. It's nice. It's actually inspired by Datalog, if you know. And that's it. From this moment on, Opa will act as your centralized policy services for service for all your policies, and every microservice can query Opa for policy enforcement. Now, Opa is nice. Opa is wonderful. It's more than nice. It's a wonderful solution. It's a very powerful solution. I agree. I really love Opa. However, when it comes to Kubernetes, not so much. Opa still requires a lot of heavy lifting work. And this is where Conftest comes into the picture. Conftest is an open source utility that allows us to write tests against any structured file. And when I say any, ladies and gentlemen, this is number one rule about me. When I say any, I mean any. I'm talking about JSON, XML, Docker files, and of course, I'm talking about YAMLs. So Conftest, in simple words, allows us to write tests for our Kubernetes resources with Opa as a policy engine under the hood. Now, Conftest is specially designed to be run in the CI or as a local testing library, just the way I like it, and even as a pre-commit hook, if you will. Now, to use Conftest, first of all, you need to install it on your local machine. Then you need to write all your policies in Rego, of course. And here you can see an example of two policies that I wrote. Now, the first policy ensures that I don't run with root privileges, and the second policy ensures that all my containers have the app labels. Wonderful. Once I wrote the policy, all the policies, I store them in a special folder. By default, the name of the folder should be policy. And then I simply run conftest test with the path of all the files that I want conftest to test. Conftest take the files that existed in that path, take all the policies, sends everything to Opa. Opa evaluates, and Conftest print the results. Now I said that you can use Conftest in the CI. So here, for example, I used GitOps action. And what I want you to pay attention to is actually here the green part. So as you can see, I pulled Conftest. And here I used one of the awesome features about Conftest, in my opinion, which is that Conftest actually allows us to push and pull our policies from a Docker registry. It's not only about containers anymore. So I pull my policy and simply run Conftest test with the path of all my Kubernetes resources that I want to test. Wonderful. Conftest is easy, makes life so much easier. I really, really love Conftest. I highly recommend at least try it. So with Conftest in the CI, now we can go back to sleep because we validate all our Kubernetes resources on every change automatically in the CI. Wonderful. Our production is safe, right? Wrong. No. Because what about criminals? What about those users with permissions that can anytime they want during the day can simply type kubectl apply and destroy our production? What about those users? And in the year of 2020, Google, Microsoft, Red Hat, and Styra, they thought the same question. And their answer was no, it's not enough. And this is the story of how they created Gatekeeper. And Gatekeeper is actually the bridge between Opa and Kubernetes API. And it allows us to validate all our Kubernetes resources natively in our Kubernetes cluster. But before we talk about Gatekeeper, what it does, why it's so nice, why it's so wonderful, I want us to talk about Kubernetes admission webhooks, and specifically Kubernetes admission controllers. You see, when an API request comes into the Kubernetes API, it passes through a series of steps. First, it's being authenticated and authorized, and then it's being processed by the admission controllers, which basically triggers a list of admission webhooks, which can mutate or validate your request. Then, and only then, if the request is validated, then it's move forward to be executed, move forward to the etcd to be persisted and to be executed. Now, Gatekeeper is installed as a customizable admission webhook. So whenever a resource in the cluster is being created, updated, or deleted, the API server triggers the admission controllers, which basically call Gatekeeper. Gatekeeper take that request with predefined policies, sends everything back to Opa. Opa evaluates the request with the policies, and if it finds any violations, Gatekeeper rejects the request and the user returns an error. So how do you use Gatekeeper? First, you need to install Gatekeeper on your cluster. Then you need to write all your policies. Now, since Gatekeeper is installed on the cluster, you don't write your policies obviously in the Rego files. You need to use the constraint template CRD. So as you can see here as example, I created a constraint template and for policy, and I call it Kubernetes required labels. And once again, I want you to pay attention to the green part, because this is actually the policy, the actual policy that I want to enforce. And the policy accepts a required label and checks if it exists in that resource. Now, after I wrote the policy, I need to tell Gatekeeper on which kind I want this policy to be applied to. And for that, I need to use the constraint. So as you can see here, I created a constraint that takes the Kubernetes required labels and applies it on every namespace with the owner label. So in conclusion, this policy checks that for every namespace, we'll have the required owner a label. Wonderful. So with Gatekeeper in the cluster, Conftest in the CI, we finally gain very powerful enforcement for our Kubernetes resources. So first of all, very nice, a tap on the shoulder, wonderful. However, there are a couple of challenges that I want us to talk about. First of all, you see, as your organization grows, you probably need to modify or change the policies that you wrote. You probably want to create new policies or to delete one of the existing policies. Now, this can be a very challenging task when your policies are written both as Rego files and as a constraint template CRs for Gatekeeper, especially if you have many Git repositories. So one of the ways to face this issue would be by using a dynamic YAML that you can download from S3 for all your configuration. Another way would be to use etcd as your centralized place and to pull your configuration from it. Now, there are many ways to face this challenge, but it's important to take this challenge under consideration. Another challenge that I want us to talk about is actually the Rego language itself. You see, I know, I said that Rego is very easy to learn. However, it's very hard to master. And I know this because actually when we created our policy as code feature, we searched for policy languages. And one of the languages was actually Rego. And if your policies are pretty straightforward, then you shouldn't worry about Rego at all. But if your policies will require some level of complexity, like to check if one of the keys is within a range of numbers, or to check if a key uses a specific type of units, or to check if a key is, and to compare it with another key in that file or in another file, this can be a little trickier for Rego. So my fair advice to you is to look for open source projects, or to look for tools that maybe already come with some built-in policies, or at least to some Rego policies that you can take and to get inspiration from. So if you think about it, another way to face these challenges would be by not using Gatekeeper at all, and to guarantee that your Git repository is your single source of truth. And by that, eliminate the users from being able to kubectl apply whatever they want, whenever they want. Some people might call it GitOps. I'm kidding again. Now, I know that there are many tools that you can use to practice GitOps, but the tool that I want to talk about today is Argo CD, because I really love Argo CD. It just makes life so much easier, and that's basically it. So Argo CD, as the name tells you, is a continuous delivery tool, but the magic about Argo CD is that it is specially designed for Kubernetes, and it allows us to continuously deliver natively in Kubernetes. So to really understand what Argo CD and what is the essence behind Argo CD, I want us to first talk about how does the CD workflow looks like without Argo CD. So let's say that I have Kubernetes cluster in production and I'm using Jenkins for CI/CD. Now, you know the drill. Usually developers, they submit their code, their feature, I don't know, maybe new bug or something, and they trigger the CI pipeline. In the CI, we test the code, we build a new image of the application, and we push that image to a Docker registry, and then we update Kubernetes resources, usually a deployment resource, with our new image. Then we apply it to the cluster. Great. Now, there are a couple of challenges in this workflow. First of all, in order to kubectl to fully function, we need to give it some access and credentials to our Kubernetes cluster. The second thing is that we need to configure it with some credentials for AWS, because I personally use the EKS. And not only that this can be a configuration challenge, but it also can be a security challenge. The second challenge that I want to talk about is that once Jenkins, for example, deploys our deployment, we don't have any visibility over that deployment status. We don't know if it succeeded or if not, what failed. We need to manually check the logs in our cluster, which can be very difficult sometimes. Argo CD is built just for that, to make continuous delivery, to make continuous deployment to Kubernetes more efficient. And it does it by simply reversing the flow. Instead of pushing the changes to the cluster, it pulls those changes from the Git repository. And the real magic is that it's actually part of the cluster itself and its extension of the Kubernetes cluster. So you don't need to provide any credentials or any secrets in order to Argo CD to fully function. But let's talk about it in more details. So first of all, you need to install Argo CD on your cluster. Then you need to configure it with Git repository. So you need to tell Argo, this is the repository that you should monitor. Then Argo will monitor that repository and will pull changes from it every 3 seconds by default. When Argo will detect that a new change were made, aka the commit hash is different now, then it will clone the repository and will apply all those changes to the cluster. Now, you're probably wondering right now, what will happen if we'll type kubectl apply directly to our cluster to manually apply changes? Now, since Argo CD is installed on the cluster, then Argo controller will detect that something was changed and that the cluster is out of sync with the repository. Argo will once again take the repository and will override those changes, making the repository our single source of truth. Now, side note about repositories, because I talked about it a lot. It's been established as a best practice when you work with Argo CD and with GitOps to separate between the application source code repository and the application configuration. The reason why is because you usually have more than one deployment, of course. You have you have services, you have config maps, namespaces, ingress, you have lots of other config files, and you also probably need to manage them with Customize, with Helm for different environment. So you probably don't want to trigger the CI pipeline for every time that you change the service, because nothing really changed in the application. And for that, it's very recommended to separate between the two and to have one repository for all the application source code and another repository for all your configuration. Usually, this repository is called the GitOps repository. Great. So Now, let's see how a CD workflow looks like with Argo CD. So once again, a developer submits a new code to the upstream, which triggers our CI pipeline. We test the code, we build a new image, push that image to a Docker registry, and then the CI updates the deployment configuration in a separated repository. That repository is the repository that Argo CD watches. And when we'll submit those changes, Argo will pull those changes and will apply them to the cluster. So if we'll use Conftest here in the CI of the GitOps repository, we'll once again gain the powerful enforcement that we wanted. And we guarantee that this repository is our single source of truth for our clusters. Now, the great news is that you have wonderful policy enforcement. Bad news is that this is only the beginning, because policy management should continuously evolve and continuously updated according to your organization needs. And this is where the centralized policy management comes into play. So to build centralized policy, first of all, you need to make sure that you have the right environment to dynamically adjust your policies. You need to have the place where you can implement, update, create, and delete those policies. You can use Git, but I don't recommend you to do so, because Git is there for version control, not for management. What will you do in a Git, for instance, with permissions? You probably need to be able to control over who can create and who can delete a certain policies. So Git is there for version control, not for management, and you still need to be able to dynamically adjust the policies in your organization and manage them according to your requirements. The second thing that I think you should consider is the ability to continuously affirm that your policies are actually effective. You see, the thing about policies in Kubernetes is that they're sort of like a contract between the application owners, the cluster admins, and the security stakeholders. And for those policies to be actually effective, we don't only need to write them and to make sure that they work, we also need to make sure that they are being communicated properly between everybody in the organization. So for that, we need, first of all, to have the observability of all the policies execution in our organization, because we need to be able to continuously review, monitor, and control those policies. For instance, how can you tell which policies are actually being used in practice? How can you tell which policy fails the most, or that people actually know how to fix their policy once it's been failed? These questions is some things that you should take under consideration when you will build your centralized policy management. And the last tool that I want to talk about is my very own the Tree CLI, a open source project, which is actually sort of a combination of all what we talked about. So the Tree is a CLI solution that, just much like Conftest, allows us to scan our Kubernetes resources for violations. And the way that it works is that it runs automatic checks on every resource that exists in a given path. After that check is completed, we display a detailed output of all the violations for all the misconfigurations that we find, with guidelines of how to actually fix them. Now, under the hood, every automatic checks include 3 steps. First, the YAML validation to verify that this file is actually valid YAML. Then we'll check for schema validation to verify your file against your Kubernetes or your Argo schema. Then the last step would be the policy checks, which validates that resource against built-in rules for Kubernetes and for Argo best practices. Now, in general, the tree can be used in the CI or as a local testing library or as a pre-commit hook, just like Conftest. And in addition to the CI, to the CLI, the tree, we provide a dashboard application where you can create your policy, modify those policies, and review all those policy executions in your organization. To use the tree, all you need to do is to install it on your machine and simply execute it with the tree test with the path of all the files that you should test, you want to test, and it's free, it's open source. So I highly recommend everybody review the code, submit a pull request. I'll be there. Don't hesitate to reach out. I really hope that this session inspired you to think about what are the policies in your organization? How do you want to enforce those policies? And thank you very much for being with me.